Ever wondered how your voice assistant wakes up every time you call its name? It's not magic, it's artificial intelligence, or AI for short. AI is now so woven into the fabric of our lives that it's almost impossible to imagine a world without it. Whether it's suggesting the fastest route to work, filtering spam emails, or even helping doctors diagnose diseases, AI is everywhere. But what exactly is AI? Well, in the simplest terms, it's a branch of computer science that aims to create machines that mimic human intelligence. Sounds complex, right? But don't worry, we're here to make it simple. We're going to pull back the curtain on AI, revealing the intricate gears and cogs that make these intelligent machines tick. So are you ready for a fascinating journey into the heart of AI? Great! Hold on to your seats as we delve into the exciting world of artificial intelligence. So, what does it take to create an AI? Well, let's dive right in. The very first step in building an AI is defining the problem. This may sound simple, but let me assure you it's anything but. The problem needs to be something that AI can actually solve, so we need to think about what AI is good at. Pattern recognition, automation of repetitive tasks, and making predictions based on large volumes of data. These are all strong suits of AI. Once we've defined our problem, the next step is data gathering. Data is the lifeblood of AI. It's the fuel that powers the machine, but not just any data will do. We need the right kind of data. If we're trying to build an AI that can predict the weather, for example, we'll need lots of historical weather data. If we're building a speech recognition AI, we'll need a vast amount of audio data. But gathering the data is just the beginning. Once we have our data, we need to prepare it. This is a step that often gets overlooked, but it's crucial. Data preparation involves cleaning the data, dealing with missing values, and transforming it into a format that our AI can understand. This is a meticulous process, but it's absolutely worth the effort. Now that we have our problem defined and our data gathered and prepared, the next step is choosing the right AI model. And there's quite a variety to choose from. There are neural networks, decision trees, support vector machines, and many others. The choice of model will depend on the problem we're trying to solve, the nature of our data, and the results we're aiming for. Each of these steps plays a vital role in the creation of an AI. They lay the foundation for the sophisticated machine learning algorithms that make AI possible. They're the blueprint, if you will, for our AI. With these steps, we have set the groundwork for our AI. Now let's bring it to life. Ready to breathe life into our AI? Let's dive right in. The process of creating AI, similar to raising a child, requires patience, diligence, and a lot of learning from mistakes. The heart of this creation process is called training the AI model. Think of your AI model as a student and the data as the textbook. The training process involves feeding the model massive amounts of data so it can learn and make sense of it. Just like a student studying for an exam, the AI model uses this data to understand patterns, relationships, and structures. But how do we know if our AI model is learning correctly? Enter validation. Validation is the equivalent of giving our student a pop quiz. It helps us gauge the performance of our AI model. We use a separate set of data, unseen by the model during training, to test its ability to predict outcomes accurately. If the model performs well, it's a sign that it's learning as expected. If not, it's back to the drawing board. Now you might be thinking, well, that seems straightforward enough. But here's where things get interesting. AI models are not one-size-fits-all. They need to be tuned for optimal results. This fine-tuning process, also known as hyperparameter tuning, involves adjusting various parameters within the model to improve its performance. It's akin to tuning a guitar to get the perfect sound. It's a delicate balance, and finding the right settings often involves quite a bit of trial and error. The journey of creating AI isn't always smooth sailing. You'll likely encounter challenges along the way. One common challenge is overfitting, where the model performs exceptionally well on the training data but fails miserably on new unseen data. It's like a student who crams for an exam, remembering all the specifics but failing to understand the broader concepts. Another challenge is underfitting, where the model fails to grasp even the patterns in the training data, much like a student who hasn't studied enough. Both overfitting and underfitting are undesirable, and striking the balance between them is crucial for a successful AI model. There's also the challenge of bias in AI. If the training data is biased, the AI model will inevitably learn these biases, leading to skewed results. It's a reminder that the data we feed into our AI is a mirror of our world, with all its imperfections. But don't be disheartened. These challenges are part and parcel of the AI creation process. They're not roadblocks, but stepping stones to a better understanding of AI. They allow us to learn, adapt, and improve, shaping our AI model into a robust, reliable tool that can help us navigate the complexities of our world. Congratulations, you have just trained your first AI model, but we're not done yet. The journey of AI creation, much like any journey, is filled with twists and turns, highs and lows, and a whole lot of learning, so buckle up and let's continue the ride. Now, how do we ensure our AI is ready for the real world? That's a great question. Once we've created our AI, it's time to put it to the ultimate test, real-world conditions. This stage is all about testing, deploying, monitoring, and updating where necessary. So let's dive right into it. The first step is testing. This is where we check if our AI is working as expected. We present it with new data, different from what it's been trained on, and see how it performs. If it's not up to par, we'll need to do some tweaking. Remember, it's okay if your AI doesn't work perfectly the first time. The key is to learn from these tests and make improvements. Next up, we have deployment. This is the stage where we release our AI into the real world. It's a thrilling moment, but it also comes with a lot of responsibility. We must ensure that our AI is safe, ethical, and beneficial to its users. Now, once our AI is out there, our job isn't done. We need to continuously monitor its performance. Is it doing what it's supposed to do? Is it improving over time? Are there any unexpected issues cropping up? Regular monitoring helps us catch and fix problems before they become major issues. Lastly, we have the updating phase. This is a continuous process, not a one-time thing. The world is constantly changing and our AI needs to adapt to these changes. So we need to keep learning, keep improving, and keep updating our AI to ensure it stays relevant and effective. Remember, creating an AI is not a sprint, it's a marathon. It takes time, effort, and a lot of patience. But trust me, the reward is worth it. Seeing your AI in action, solving problems, and making a difference, there's nothing quite like it. And there you have it. Your AI is ready to take on the world. Now let's go out there and make a difference. So, what have we learned today? We have traversed the fascinating realm of artificial intelligence, or AI. We've pulled back the curtain on the mystery, revealing the blueprint of this advanced technology. It's not just a black box of algorithms and data, but a meticulously designed system built to solve specific problems, make predictions, and learn from experience. Our journey began with understanding the problem. This is the cornerstone of any AI creation. You can't build an AI without knowing what problem it's meant to tackle. From predicting customer behavior to detecting anomalies in medical images, defining the problem is the first and most crucial step. We then delved into the blueprint of AI, shedding light on the underlying algorithms and data structures that power these systems. We learned that AI is not a monolithic entity, but a constellation of different techniques, from machine learning to deep learning, each with its unique strengths and applications. In the making of AI, we saw how to train our model using data. We fed it countless examples, allowing it to learn patterns and make predictions. It's like teaching a child to recognize shapes or colors, except it's done on a much grander scale. The finishing touches involve deploying and monitoring the model. An AI is not a set-it-and-forget-it tool. It requires constant monitoring and tweaking to ensure it's performing optimally. And when it's not, we need to be ready to step in, tweak the model, and retrain it with fresh data. Summing up, creating an AI is a journey, a blend of science, art, and a whole lot of patience. It's about understanding the problem, choosing the right techniques, training the model, and constantly refining it. This journey is not always smooth, but it's certainly rewarding. So, the next time you ask your voice assistant for the weather, remember you too can create an AI just as sophisticated. Until next time, keep innovating.